Hey, welcome back. This session's about the Java comparable interface. You can say it comparable, I can say it comparable, I can say it both ways. You say tomato and I say tomato. But what an interface is something that a class is obligated to implement. And in the case of the comparable interface, it's simply the CompareTo method. You won't have to know this form yet. We'll look at creating our own interface going forward. But what the comparable interface does is allow you to order objects, such as to put a list in alphabetical order, or to order them from greatest to least or least to greatest. That's what the comparable interface does. And in specific, what's highlighted here, the CompareTo method. And in a little bit, we'll show you how to create a class that implements the comparable interface, but we'll stick here with what it does. So the numbers to remember when thinking about the comparable interface are negative number, something that's less than 0, 0, and a positive number. So if I compare myself to someone else and I happen to be shorter, it will return a negative number. If we happen to be the same height, it will return 0. And if I happen to be taller, it will return a positive number. So remember that the int in this CompareTo method here will return a negative number, a 0, or a positive number. So again, if John comes before William, it will return a negative number. And if John comes after Bill, it will return a positive number. And if I'm comparing John and John, spelled the same way, capital J in both words, then it will return a 0. So what the comparable interface does is allow you to compare objects. So any class that implements the comparable interface enables a comparison of objects of that type. So a lot of classes will go ahead and implement the comparable interface so that they can be put in order. If you have, at a later example, a collection of those objects, say in an array of names, you would be able to sort that array in alphabetical order. So here's some examples of it. And for example, you can compare employees that say, get my ID and compare to your ID. So you can see that it comes in as an employee O, and you compare the IDs of the two employees. So you can get a sense of that. But we'll skip away to codeboard.io, and I'll show you my class, which is an inventory item. Well, take a look. The first line is the most important. Public class inventory item implements comparable, and in angular braces is the name of the class again, inventory item. My inventory item consists of a name, an item number, and an item quantity, and as well has a constructor that takes in n, num, and quantity, and sets the instance variables equal to those values. In lines 13 through 21, we have accessors. So if I ask get name, I'll send you back my name. Get item num, I'll send you back my item num. And get quantity, I'll send you back my quantity. We also have two methods that I think are useful. We've covered them before in terms of overriding the object class methods, toString and equals. So the toString returns a string form representation of the object, and equals compares one object to another. And that's not really enough. It's not enough to know that they're equal or not equal based on item num or inventory num, because it just simply answers yes or no, they're the same or not. We need to return 0, -1, or 1 or 0, a positive number or a negative number, to be able to order them. So if you look very carefully at my CompareTo method here, let me just adjust the screen, you can see that if item num equal other dot get item num, I'm using the accessor up in line 16 to get the other's item number. If they're the same, return 0, which is, by the way, the same answer that the equals method on line 25 provides. So yes, CompareTo also does the work of equals. But if my item num is greater than the other item num, I'm going to return 1, or a positive number. I've chosen 1 here, but you should understand it as being any positive number. So I could change that to 15 and it would work as well. And then else I return -1. 3 states, 0, 1, -1, 0, positive number, negative number. What the else condition on line 31 is testing is actually if item num is less than the other item num. So if we're comparing numbers, for example, we're basically putting them in order. Now we're just comparing two items, one after another, but let's take a look at how it works. Here I have a main program that creates a first and a second inventory item, and they're both named saw, which is why I don't use the name to do a comparison, because my hardware store would have two saws, okay? But the inventory item for the first is, oddly enough, the number 2, and the inventory num for the second is inventory item 1, and the quantity is 10 and 15 respectively. So here I'm going, if first dot CompareTo second is less than or equal to 0, which isn't the case, because what happens is the first comes after the second in terms of item num. It will output first and second. Else it'll output second first, which is what should happen. So I'm just going to get this back to normal and pull it up a little bit and run it. And that's exactly what happens. It outputs first, which is inventory number 1, that has 15, and then it outputs second. It outputs second and then first. By the way, you might be unfamiliar with this. This forces a new line. It's a \n, meaning give me a new line, and that's why this appears on two different lines. You'll know that also when I just simply put second or first, we're calling the toString method back in the inventory item class, and we've covered that in a previous lesson. So let me switch it up here and say that this is 5. Okay, so that basically it should output inventory item first and then inventory item second. And that's exactly what happens. So here's the takeaway. Computers are used to store vast lists of things. Amazon has a bazillion inventory items. There are all the students in the school. There are all the classes. There are all the room numbers. Some way, each item is given a unique identifier, which in this case is item num. It's only given to them and them alone. Just like your student ID number is your student ID number, never reissued to anyone else. And once we create that unique identifier or property for each class, we come along with a CompareTo method as part of implementing the comparable interface, and we put things in order. Because humans really like to collect things and to put them in order. It's what we do. From the moment we first started collecting seeds to plant them in the following year, we're collectors. Deal with it. Okay. Max out.